Hi everyone, so we're back again with another daily physics revision question, and I'm going to do some feedback on yesterday's daily physics revision question, which was about these wireless charging stations for, I remember to bring it in this time, for mobile phones. So how does wireless charging work in mobile phones, basically? But the daily physics question today is again about generators. It's again about electromagnetism, because that's the request that I've had. Here we go. So compare a dynamo and an alternator in terms of their design and their output. That's the GCSE level stuff. A level stuff, you've got to add on top of that. Generator output can be smoothed by using capacitors in parallel with the generator. Suggest what considerations designers of these smoothing circuits will need to make. So the first one is basically compare a dynamo with an alternator in terms of their design and output. And the A levels need to add to that. The generator output can be smoothed using capacitors in parallel with the generator, and suggest what consideration designers of these smoothing circuits will need to make. So you're talking about, in that second part, the A-level kids, you're talking about the designers of the smoothing circuits, not the actual dynamo and the alternator. Okay, I've brought in a dynamo. This is a demonstration dynamo from Philip Harris. It's quite a good one. It does have a little LED on the front there, which can demonstrate that. There. It can demonstrate that the LED will light when I turn the dynamo in a certain direction, but not light in the other direction. Can you see that all right? I think you just about can see it. Lights in that direction, doesn't light in that direction. This is the magnet here, which I can switch the magnetic field. So now it does light in that one, doesn't light in that one. Okay, that's probably enough of the annoying sound, but that's a little clue. I really like this, by the way, because of that thing. I've just noticed this has got a one of these, which I don't want to give away because it might be part of the answer. Watch when that turns, that little thing at the end there. Watch when that turns, there's a moment where it changes the side that it's connected to. Let's get it focused up on that for you. Changes the side that it's connected to. Okay, now this is a slightly different design because it does have two coils, but you can see it as being a similar idea to the ones that you've seen in the diagrams you've seen in the books. Okay, that is today's question, and I'm going to go back to the feedback in terms of the way they built the design and the output from them, and the A-level idea need to add this idea of smoothing. What do you need to consider when you're designing a smoothing circuit for either of those two generators? Okay, so this is what the last question was about. It's this wireless charging station. So most, certainly all flagships, most mobile phones can be wirelessly charged now. This is my old one sitting on the wireless charging station there. So how does it work? People got pretty close, but this probably was one of the poorest answered questions from both GCSE and A-level students. Possibly Rachel got the closest. You needed to basically recognize it's a transformer. You recognize it's a transformer, and you put down the standard explanation of transformers, which Rachel got. I'll go for hers. In the base charging unit, there's an alternating current passed through an induction coil. This produces a magnetic field at right angles to the current, only that, which alternates. Okay, so it's a changing magnetic field, importantly. A mobile phone also has an induction coil inside it. So inside this, there actually is another coil of wire. Okay, it's quite flat, it's quite small, doesn't get in the way of all the other gizmos inside there as well. But there is a coil of wire, which it's the pickup coil. You could talk about that, that also has an induction coil, which will have an induced alternating current. So Rachel didn't actually say that in there as well. So unfortunately, they didn't get the last part of the transformer explanation, which I'll just bang out for you now. Transformers, when you see transformers, recognize that's a transformer. You're going to state there's an alternating current in the primary coil that makes a changing magnetic field, which induces an alternating current on the secondary coil. We should really say an alternating EMF, but most examples will accept a alternating current because an EMF causes a current. Okay. Then there was some good discussion. But Rachel did get is connected to a rectifier. So a rectifier is an important idea to understand. A rectifier is basically a diode, or it's a diode circuit sometimes, which means that you don't have the current change in direction when charging the phone. If the current was to keep changing direction, then the net charge would be 0, so there would be no energy input into the thing. Rachel says she did. Okay, I apologise, well done. I did think you got all 3 of those, okay, Rachel, so well done. But you just need to make sure that you say all those things. And then you got the rectifier circuit, which is fantastic, okay? Basically, if you didn't have a rectifier, then it would sit there and there'd be an alternating current in the wire, but the battery wouldn't charge. You basically need, as it changes positive to negative, positive to negative, positive to negative, you basically need to cut out all the negative parts. So the current is just going positive, positive, positive. Okay, I can kind of draw that if you like. If we've got an alternating current induced, like this, well, that wouldn't be any net kind of gain of charge for the battery. So the rectifier just cuts out one direction by using a diode. Now, none of even the A-level kids got this idea. So you need to rectify, that's rectified AC into DC. Now, it's only one direction of voltage, only one direction of current, so we can charge the battery. I also asked A-level students to refer to a physical law, and they didn't get it, which is Faraday's law of electromagnetic induction. The EMF is proportional to the rate of change of flux linkage. So EMF is equal to minus, that's Lenz's law, we didn't need to state that in this question, but you needed to state, this is an example of Faraday's law of electromagnetic induction. A rate of change of flux, that's phi, linkage, that's N, and T, which is time. Okay, so rate of is anything over time. Very important to get that in there. So what considerations can you actually, to increase the charging voltage that's made by these things, what can you do? Well, you can have more turns, more N, more linkage. So basically you could design, you need to make sure that you do design the coils in these things with as many turns as you can fit, because the greater the N, the greater the EMF. Now also a larger kind of current in the first coil, the primary coil, would mean a larger magnetic field, a stronger magnetic field. So that would be a greater phi, a greater flux. So that was one you could have noticed as well. But also, and I think this is the interesting one, is actually the way in which these do actually use this law to increase the EMF as high as possible, is they have the time as small as possible. So lower number down here means a bigger number over here. Okay, that's how fractions work. Essentially, by having the highest possible frequency of alternating current that they can in the primary. So the highest possible frequency of alternating magnetic field that they can. So therefore, the highest possible EMF induced on the pickup coil, on the secondary coil in the phone. That is a really interesting application. You can see loads. I think it's one of those things that people, if you Google some videos where they're taking apart mobile phones, you'll see that induction coil on the back there. It doesn't take up much space, although it is physically large. The wires don't take up much space. They're quite compact in there. Okay, so I thought that was a really interesting question. I hope you did too. This one is about dynamo. So you've got to compare a dynamo and an alternator in terms of their design and their output. The A-level idea is talking about the smoothing with the capacitors and what considerations you need to make to design those smoothing circuits. Thank you very much. I'll have a quick look at the chat in just a moment. At any time you can go, there's a playlist in the description with all of these questions you can go through. You can go back to the last one. Rachel's answer was really good. Harriet's answer was good. I think you need to make sure that you mention alternating current. It doesn't work if this is DC. It doesn't work if this is DC, because then you don't have a changing flux. It has to be a rate of change of flux linkage to induce an EMF. All right, so I think I'm going to leave that there pretty much. Thanks, Rachel. How complicated do you think a forces diagram question in paper 2, and what's the hardest question they could ask you about forces? They could ask you some pretty tricky ones, to be fair, because you are expected to be able to handle vectors in 2 dimensions. Most forces questions are going to be about pairs of forces, so they're going to maybe about a falling object, you know, where weight is greater than drag, so it's accelerating, something like this. Okay, but they could ask you some tricky ones. Often they'll add, you know, 4 like this. Okay, maybe there's a tension here and a friction here. So maybe you've got 2 different equilibriums, and maybe this is weight and the reaction force of something sat on a table or something like that, being dragged along by a rope. There's loads of things they could ask you. They could, and they might well do this. They might talk about all these things, so friction backwards, and have the tension pulled at an angle, in which case you would need to resolve this tension in its x and y direction to do any maths with it. So they could ask you to do that. That's probably as hard as it's going to get, is maybe having one angle with a set of, probably with just another 1 or 2 forces rather than all 4, but that's really where it's going to go to. There is no, they haven't specified this is as hard as the question we're going to ask. But they have said that you need to be able to handle vectors in 2 dimensions, so given angles or given Pythagoras information, and they have said you need to be able to use and understand forces diagrams. So hope that answers your question, kiddo. Hi, XMay, XO, XXXO. If there's a nuclear fission question asking about the process of nuclear fission, do you think a labeled diagram is enough to write? Probably. Most of the time with labeled with nuclear fission, they're asking for the idea that large nuclei decay into smaller nuclei, and they're asking the idea that more than one neutron is released each time, and that those neutrons go on to start further fissions, and that that leads to therefore a chain reaction, and that can be controlled by capturing the neutrons, that type of thing. So yeah, a labeled diagram, if it's accurate, but I would learn it, I would just learn those little statements as well. So fission, large nuclei split to make small nuclei, gives out neutrons, more than one neutron, so each fission causes maybe 2 or 3 other fissions, and that leads to a chain reaction, very rapid, lots and lots and lots of fissions happening. So yeah, I would learn a few sentences. I think the difficulty with those diagrams is people learn them, they know what shape they are roughly, but they don't learn them in the detail. So if you link some words to the diagram, I think that's a lot better idea than just learning the diagrams, because you don't want to put the diagram down and forget to label part of it. That's the key part of it. I would have a few memorized sentences to help you out in any situation there. Oh, it's Ramadan, is it right now? Okay, Ramadan, happy Ramadan to everybody. I'm never quite sure. Do you say Ramadan Mubarak? I think do you only say that you only say that at the end, is that right? Or is that Eid Mubarak? But I know that you'll be looking forward to iftar this evening. Luckily, it's slightly earlier, because last year I think Ramadan was during the exam season. That was really tricky for everybody. So let's have a little look. Is 6 hours enough? Not yet. Thanks, buddy. 6 hours of sleep is enough in the exam season. 6 hours of revision. You've got to do your best, haven't you, in the Ramadan? 6 hours sleep is okay. I would probably. I know that I actually had a chat with. I can't remember his channel name. I'm thinking it's called Mr. BizCon Sesh, which is it's a business studies channel, and because he's Muslim, he was talking about dealing with exam stress in Ramadan, and he was talking about make sure you get that. When you're not at school, make sure you get that nap in where you can, or at least the rest time during the day, because you do need to make sure you have your family relaxing time and that you eat well. So you can't shift any of that to make sure you get the sleep. I would get as much sleep as you can. I would fit in the revision that you can, but if you're tired and you're struggling to concentrate, then I definitely wouldn't use my time doing any stressful revision. I would try and make sure that I was taking care of my body and relaxing and things like that. I think that's my best advice for you, May, okay? But maybe it's worth a little Google to see if there's some advice. Oh, it starts on Sunday, yeah. I would maybe consider a little Google, YouTube search, like how to deal with exams during Ramadan, how to revise during Ramadan. Because I think that there'll be people more in the know than me. Okay, all right, buddy. Yeah, I hope you have a good one. You can say both. Okay. All right. Well, thank you all very, very much for watching. Look back in the playlist, which is in the description there. Happy revision. I'm considering how long I'm going to keep this going for. I'm going to do certainly a few more. Certainly going to do until the end of this week, but then I've got a bit of a different idea for next week. So let me know if there's anything. Let me know if there's anything else that you do want to see. But I've got some ideas for your revision next week. It's starting to get pretty real, isn't it? A couple of weeks to go before any kind of real GCSEs or A-levels. This question for you today is all about generators. So look back to the start if you want to see the little demonstration that I did. Compare a dynamo and an alternator in terms of their design and the output. And the A-level idea is generator output can be smoothed using capacitors in parallel with the generator. Suggest what considerations designers of these smoothing circuits will need to make. See you later.